Okay, you should be in your notebook on the page that says Investigating Electricity and Magnetism. And we're going to work further with circuits. So today, if you look at this picture's on my computer, but it should be at your station, we are going to have new components: a battery holder, a bulb holder, a switch, and an extra wire. And now you're going to make a circuit using those materials provided. And I want you to think about the switch, what that does, and what these new materials, why I gave them to you. And so pause the video and talk about in your group why I would have given you these materials. Okay, so here's the materials that you had in the beginning that you did last class, where we made the light bulb light up with 2 wires and a battery. Well, now you're going to get some more materials. Again, you're going to get a switch, you're going to get a bulb holder, an extra wire, and a battery holder. So hopefully in your discussions you thought about that these bulb holders and battery holders are going to, and this extra wire, are going to help us maybe control the battery situation so that we don't have to hold it by hand. Remember, it was really hard to hold it by hand. So that we're going to make a more sustainable circuit, a circuit that'll last us a while. And the switch will also help us with the circuit, because it'll turn it off and on so that we can control the energy so we don't run out of our battery, so that we can keep our light on when we want it to be and off when we want it to be. You will also see in your bucket a magnet and a compass. We're not going to use that yet, but we're going to use those as tools later. So don't worry about that yet. In fact, I don't even know if we're going to use the magnet. We'll see. But so anyway, now I want you to put the circuit together using all the materials now. And if you need some help, ask each other, but I'm going to give you a pointer now. When you're putting this together, you got to make sure that your wires are touching metal. Okay, so you can unscrew like the switch and make sure that your wires are touching that, and you can, to keep your wires still, you can screw these back on. Okay. You're going to want to keep your switch up until you're ready to go. So kind of keep it open. Your bulb will go in that bulb hole pretty easily. And then again, you're going to want your wire to be wrapped around kind of tightly into these prongs here so that you have metal touching metal. And then also another hint, if you need it, is the wires. You're going to want them to go in this like side casing right here. As long as they're touching metal of there, and you can kind of stick it in there and try it. On the outside, you should be fine. And then just make sure, of course, that you're putting your battery in correctly, that the positive side is matching up and the negative side is matching up. So now I'm going to have you try it, work with your group, see if you can get it to light up. Pause the video. Okay, now I'm going to show you a circuit over here that is done. So here's one. The switch is open, but if I turn it on, the light comes on, and of course I don't want to leave it on, so I'm going to turn it off. But if you've still struggled and you wanted to see this, just make sure you can see. I'm going to go close up. You can see that my metal is touching metal, and the prongs, I even made like a hook so it would stay hooked on. On the battery, I hooked it into the side pretty tight so it wouldn't come apart. And then on the switch, again, I kind of hooked it on underneath the knobs and then screwed them back on. And then I can do the switch turn off and on. All right, so let's go back. So we've done our circuit, but we haven't even put anything in our notebook yet. So do we have evidence of electricity? Well, obviously, I want you to pause and talk about it, but hopefully you see some evidence. Okay, so now you should talk about, you have evidence that there's electricity because the light bulb came on. So talk about that. What's happening there? Remember, our electrons are going from the negative side. They're traveling through our wires, through the switch as a conductor, through the wires, to the bulb, and lights it up, and then goes back to the battery, creates this, because the opposite side of the battery is the positive, because our negatives and positives attract, causing this loop. But now we're going to go back to our paper here, and now we're going to talk about evidence of magnetism. And this is where we're going to get into our notebook, where we're testing for magnetism, okay? So right now in the left box, what do you think we're going to do? We're going to draw our model, so you should draw our entire model on the left side, label the switch, the battery, the light bulb, the wires, all that good stuff. But how are we going to test for magnetism? I gave you a tool. So hopefully you all have figured out it is the compass. So right now we're gonna notice that when the switch is off, You're going to put your compass up to yours, so do that now. Put your compass up and kind of put it on a wire. Okay, and you should see it just kind of sits there, not really doing much. It just kind of sits there. And I'm going to put it under a wire just to see. Okay, let it settle. And let's see if it does anything when I turn it on. Sometimes it's hard to see. Okay, usually, let's see if it moves. Okay, here it's moving. Okay, I don't know if you can see it or not. You really can't see it very well, can you? Try it again. I want to lay the wire out a little bit. It's hard to do it with a camera in my hand. But what you're supposed to see is the compass is kind of sitting here on the wire, and then as we shut it and turn it on, you kind of saw it there. You're supposed to see your compass switch. I can't do it very well in the video, but see if you can get your compass, like play with it. Put it above the wire, under the wire, put it, you know, close to the battery, whatever. Try it, maybe even go under, but have it real close and see, keep it still and see if when you turn on the switch, if you see your compass move. Okay, so try that. So now on your notebook, you're going to pause the video, and on the left, you're going to draw the compass pointing one way, and with your whole circuit. You're going to redraw your circuit on the right, and you're going to see, you're going to draw it with the compass move, so you can see that. Hopefully you see this magnetism. I couldn't get it to work as well with me doing it with one hand. But what I'm trying to get you to see is that compass moved because when you turned on the electricity, what you're creating around these wires is actually a magnetic field that we're going to talk about a little bit more later on. But electricity actually creates a magnetic field that goes around these wires. And if you take your magnet now, you might see, you can kind of play around with your magnet when it's turned on, see if it will kind of do anything. Like right now, I feel like it's really attracted here to the wire. But if I go this way, it kind of feels like it's pulling away. So just see if you can kind of maybe feel a little bit of a pull and a little bit of a push as you kind of try the north and the south poles. Sometimes you can't see it, feel it as well as others, but you might feel a little push and a little pull just to kind of get that feel of magnetism. And then in your models, as you showed the magnetism, it says use your model to describe the observations in space below. So just kind of talk about when the circuit was off versus when it was on. Did the compass needle move? And when it was off versus on. It won't move a lot, I will say, but a little bit. And then up in your right-hand box here especially, I want you, since you're turning it on now, I want you to talk about energy transfers there. So what are those energy transfers from the battery through the wires? So pause your video and update that. Well, what's going to be different here now is when you draw this picture, and you talk about at the battery there's chemical energy that gets turned into electricity. Now you can say not only does it get turned into electricity, it gets turned into electricity and magnetism. Then it goes to the light bulb where it gets light and heat. So there is actually another energy transfer that happens at the same time when you turn it on through the wires, that it not only turns electricity, it actually turns into a magnetic field as well. And so we will play around with this a little bit more if you couldn't see it real well on this, where we will actually combine electricity and magnetism, because that's really something that they do a lot in the real world.